Hello.
Hi, Mr. Ma.
Hi guys, can you hear me? You guys hear me?
Yeah.
Yeah.
Okay. Okay. Let's see. We got so far. Got 1, 2, 3, 4, 5, what? 6. Let's begin by 5:01. It's not gonna be long for today. I decided to shorten our lessons since I think if we continue all the way to Rayman, you guys are gonna get worse than having coronavirus. So let's just settle for let's just settle for something simple for today, okay?
Okay.
What are we going to focus on instead?
We're gonna be focusing more on rates. Let me see. Because it's a little bit simpler than Raymond's sum. Okay, where can let's see. Got 8. Let's see if we could share this one out. So we're going to be discussing more on the accumulation of change. So it still is very, very similar to Riemann sum, but it's a lot more simpler. I think this would be a lot more easier for you guys to understand rather than going directly to Riemann sum.
Okay, so this is the first two assignments that you
first
have
two
in Khan
assignments.
Academy.
Yes. So I think if we go right away to Riemann sum, if we try to have this into just like one discussion, the accumulation of change and Riemann sum, I don't think it would be good for the rest of you. Some may be able to catch it up right away, but some may have a headache. So let's just settle for just accumulation of change for now. And we're also going to have like a formal introduction to what integral calculus is.
Okay, the ironic thing about that is I was able to better understand Raymond's sum than I was accumulation of change. So
Okay. I guess this will also be good for you, Danny, since I'll be explaining it a little bit more simpler. It's easy. This is very, very easy. And think of it as think of this, guys, as like surface areas. I think it's better to think of it that way. Let me just it's already 5:02. Do I swear? Okay, we got Aliana. Let me just check your attendance, guys. Oh. Yep.
Guys.
Hello. So we're missing how come I always want to so we're missing a few. We don't have Reina. Is Ashley with us? Ashley's not with us. You guys know where Ashley is, or is he okay?
I'll text her.
And we also Aliana, is somebody with you today, or are you just
I'm
with
by myself.
Oh, okay. Anybody know where Reina is? Zoe?
I just
Yes.
texted her.
Oh, okay. So we got
Sorry, I just got my the speakers working. Did you count me down?
Yeah. I did see you. So far, guys, I have here Aliana, Brandy, Savannah, Danny, Kaylee, Mateo, Wyatt, and Zoe. Mateo, did you get were you able to receive an email from me?
Yeah, I did.
Oh, okay.
Mr. Moore, I have a quick question.
Yes.
How do we, so for the pre-cal, how do I enroll from the con? Because my assignments for the pre-cal.
Oh, yeah. I think I can take you out. So the rest of you guys, I can take you out.
Okay.
That also goes for Zoe and Savannah, Reina, and so I guess, guys, shall we begin? I'm just going to, we have Ashley, missing Ashley and Reina. I hope they're okay. It's okay for them to be absent, but I hope they're okay. Okay, guys, shall we begin?
Yeah.
Okay, so, okay, can you guys see this blue screen right here? Or,
Yeah.
okay,
Yes.
okay, so, okay. All right, so guys, let's begin so again okay, we got 10 participants. So let me just admit one again. We got Ashley. Hey, there you go, Ashley. How do I? Okay. So the only one that I don't have is Reina. But I got 10. So kind of strange. Okay. Let's continue. Okay, guys, can you see this? The blue screen? There it is.
No. Not yet.
Oh, oh, not yet. Okay. Let me see. Okay. How about now?
Yes.
Yes.
Oh, okay. Okay, guys. So let's, okay, so guys, let's begin. So we're going to have an introduction first before we even begin with with our main objectives, which is the accumulation of change. Let's try first to have a little bit of an introduction of what integral calculus is. Now, again, let's begin by, let's say, we have, I'm just going to draw a graph here. So let's say we do have a function, and let's try to call this as y is equal to the function of x. So it's just like any other curve. And the main problem or the main focus of integral calculus is, okay, let's say we want to figure out the area bounded by, or the area beneath your curve, bounded by two values. So this is what we really wanted to find out. And that's the most basic idea of what integral calculus is. Now, right now, let's just try first to think of a way on how to find this area without technically doing it in the integral calculus way. So guys, can you think of any ideas on how to figure out this shaded portion right here?
Break it into
You use
pieces.
rectangles.
Rectangles. And Mateo, do you have the same idea as with Danny?
Yeah, rectangles and triangles.
Rectangles and triangles. Very good. So, but like again, but the most easiest would just then be rectangles, right? So let's say, let's try to draw rectangles, and we're just going to create, it doesn't have to be equally the same, but for in this purpose, let's just try to make them the same. And let's say the width of each of these rectangles, okay, let's just try to call them as delta x, or the change of x. Remember, guys, this is your x, and this is your y. Now, if we try to go back in first grade or second grade or third grade, what's the formula for a rectangle? Can you guys still remember what's the formula of
Length
a
times
rectangle?
width.
That's going to be length multiplied by your width, right? So in this case, what we want to do is, okay, our width could be defined by, who texted me? Okay, that's okay. So guys, so your width for this one would then be your delta x, and your length will just then be your
F of x.
your f of x. Okay, so for each strip, okay, you are going to have a delta x, which is being multiplied by your f of x. That's for each strip. Now, how do we figure out the area of this entire line? What should we do?
You would add all of them together.
So we would add all of them together. So what that means is, okay, this is the symbol when we try to add them up all together. Okay, let's just, can you guys guess what the symbol is? Who were able to
Is that a
did
sigma?
a sigma? What else? Yes, it's a
E.
sigma. It's an E. Okay, it's a letter E. And E, yeah, it's a Greek letter, which is E, which is actually which is this is where actually where our E came from. Okay, and what's the name of this E in Greek? Any ideas, guys?
It's not sigma.
Not sigma. It starts with the letter E. It starts with the
F.
letter E.
Epsilon.
Oh yeah, who got that? Was that Kaylee?
Epsilon. Yeah.
Okay, so it's the epsilon. I think I hope
Oh,
I
silly goose.
hope I got the right spelling for it. So it's the epsilon. What that means is, okay, it's the summation when we started with, let's say we started with our delta x. Let's just say we started with our delta xi when I starts with 1, and then it goes all the way. So let's say we have a delta x here that is equal to n. So as I is equals to 1, then we add it all the way up as delta x approaches n. So again, guys, this is more of an approximation. So what do you think should we do to make this as accurate as possible? Any ideas on how to make this as accurate as possible?
The smaller the rectangles, the more accurate it will be, because there will be less area either added or subtracted from the rectangles themselves.
Very, very good. So does everybody understand what Danny has just said, or is it too jargon for you guys?
So is it like making it infinitely small when we're measuring the slope?
Yes.
Very good. Very good. Very good. Very good. So
You're not Mr. Mora, Danny.
That's okay. That's okay. That's okay. So again, guys, we're trying to make it infinitely small. Okay. So if we're trying to make it infinitely small, what happens? So what that means is, if we're trying to make it infinitely small, okay, it's very, very small. So what happens to your n right here? Where does it approach? First 2 months of differential calculus, guys.
Is it 0 or infinity?
It approaches what?
0.
It's infinity, I think.
how many n's do you have? Like how many delta x will you have?
1.
As it gets smaller. As it
An
gets
infinite
smaller,
amount.
so it gets an infinite amount. So guys, here's another idea right here. So therefore, to make this more of an accurate approximation of the area, okay, what we're going to do is we're going to have your n
Approach infinity.
approach infinity. You guys getting the idea right now?
Yeah.
So again, so the more, okay, I forgot I was using it with my hand. I supposed to have it with my pen. So again, if we want to make this more accurate, what we want to do is, okay, we are going to make your delta x, okay, infinitesimally, like it a very, 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 very small. Okay, and what causes that is as this one gets smaller, okay, the value of your n gets bigger. It gets bigger, guys. Okay, why? Because you tend to divide this total area here, this total length here into smaller strips. So what that means is your n gets bigger.
So
And
n is essentially the amount of strips that you have.
yes. So n is essentially the amount of strips that we have. The more strips that we have, and if we try to add them together, okay, this is where the idea of it becomes very, very strange because we want to use the idea of infinity, okay, to be able for us to define definite values or definite numbers. Isn't that strange? We're using the idea of infinity in order for us to define definite. When we say definite, there's a certain limit. Okay. So again, we're using the idea of infinity. Let me just do. We're using the idea of infinity in order for us to get more an idea of a definite area. Now, what happens, okay guys, what happens if we make your delta x very, very small? What is the symbol when we try to make things very, very small? When we try to approach them to zero? Can you guys still remember what's our symbol for that? Guys, ideas. Kaylee, Danny, Savannah, Brandy, Ali. What happens to our delta x if we make it a little bit smaller? Very, very small. Guys, ideas.
Like what happens to the exponents around it, or what happens to delta x itself?
Yeah, what's the other symbol when we try to make your delta x very, very small? When we try to make it approach zero.
Is it
What's
your
the symbol?
integral?
Not yet your integral.
It would be delta n.
Delta n? What else? If we try to go back to our differential calculus, we're looking for the slope, right? Guys, can you still remember? We're looking for the slope, and we tend to make that slope, okay, the distance, okay, in order for us to make that slope, okay, well, technically we're still using the ideas of limits, but if we try to go back, okay, the slope, what we did first is we tried to use 2 points, right? We tried to use 2 points, and we tried to make them closer and closer until your distance is almost as close to zero but not equal to zero. What's the symbol for that? What's the symbol of our derivative, guys? Guys? Derivative, 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 derivative.
Triangle?
Prime?
Prime, y prime. And what's another way of writing down y prime?
D over dx.
D over dx. In this
Oh!
case, okay. Okay, so this is now where we try to connect our, if you try to take a look at, we're trying to connect integral calculus to our differential calculus. So this delta x, this delta x will now change into a dx, okay? Your f of x would still be the same. So we're just going to have it as f of x. Okay. Now, instead of writing the epsilon, okay, since this one is more of a, this is one from, this will be, if we're trying to use the summation, okay, or the epsilon, this is more of the crude way of trying to figure out your areas. Now, this one will now be changed into this
Your
symbol.
integral.
Yes, your integral. It's just like your big S. S stands for, guys?
Summation?
Summation. Summation from the value of your lower A all the way. Okay, if you guys remember where did that A came from, that came from your A right here, all the way to what? All the way to where, guys?
Your
Guys?
n?
N, or in this case,
Oh, b.
that would just be
E.
P. So this is what our basic integral calculus is all about. It's all about the summation of very, very small strips. You guys good?
Yeah.
Questions, clarifications with the introduction to integral calculus? No questions so far?
This is a lot better explained than the con one.
Okay.
Con one is super vague.
Super big. Yeah, it's big. It's big, but this one's a little bit simpler. It's a little bit more, I think it's a little bit more easier to understand. You guys good? But I think I think it kind of gives you, when you try to watch the videos in Khan, the reason for why I wanted you guys to watch the video first in Khan is that you would be able to understand once we get to the actual lessons.
Yeah.
That makes sense?
Yeah.
Okay. Brandy, guys, questions, clarifications? Let me just check again on Reina's. Anybody heard of Reina? Reina really
No.
She didn't answer me back.
Okay, I hope he's okay. She's okay. Okay. What happened to my... Okay, guys, let's see my sketchbook.
Yeah.
Would you
Yeah.
want guys, would you want to take a photo of it before I erase the... I think I might. Let me see if I could. Yeah, it's like I don't have enough space.
Does anyone know how to take a screenshot on Mac?
It's Shift Command 4. You got it, Wyatt? We're able to do a screenshot?
Yeah, I got it. Thanks.
Okay. Anybody else would like to take a notes, do a screenshot of it, or we good?
I got it, Mr. Moore.
We're good.
Okay. Mateo, guys?
Got it.
Kaylee, you guys good? Brandy?
Yeah.
Good.
I wrote it.
Okay. Ashley, you good?
I'm good.
Alrighty then. So guys, our next topic is about accumulation of change. Now, this one is a very, very good introduction also to integral calculus, but we're not going to be, it's more of the concept of the idea of finding the area underneath a certain curve. But in this case, we're just going to be using lines. Now, one thing about integral calculus is it's usually, when we talk about real problems that involves integral calculus, is we're looking for the rate of change. We're looking for rates. Normally we're looking for rates. We could solve volumes where it doesn't have a constant rate, where it doesn't have a constant flow. Um, let's say, guys, you run. Did somebody saw that?
No.
Okay, that was weird. Never mind. Okay. Okay. Somebody actually just crossed by my right at my back, and I'm pretty sure it's not my wife because my wife's in the bedroom right now. So okay, never mind. Okay. Okay. Okay, let's try to go back. So again, okay, so imagine you guys, I know that you guys are perfectly fit, but let's say, for example, for me, let's say I'm going to run, okay? Let's say I'm going to run for a period of 30 minutes. Now, in some cases, okay, at first rate, I might run for like maybe at a rate of 1 mile, like maybe 5 feet per second. In some cases, like in the span of that 30 minutes, okay, I might be running like maybe 20 feet per minute, 30 feet per minute. Sometimes I might go slow, it's just like maybe 3 feet per minute. So it varies over time. Now, when we try to talk about accumulation of change, we could therefore, okay, find what's the total length that I was able to run in a given period of time, even if I tend to change my rate. Does that kind of make sense, guys?
Yeah.
Yeah.
So, okay. Let me just approve one more. I think Reina is trying to get in. Okay, Reina is trying to get in. Where is Reina? What do I make? Okay, let me see. Where's Reina? Can't seem to find Reina. Give me. Manage 10 per. Reina's not there anymore. Not there. He's trying to get in, but he's gone. And she's gone. Anyway. Let me see. Okay, guys, can you see my can screen?
Yes.
Okay, so if you try to look at, so this is what's your, this is gonna be your assignment for the week. Okay, so let's say, okay, if you, let me just try to explain what this graph is all about. Okay, your y-axis, okay, normally your y-axis in this case, it's gonna be your rate. Okay. And your x-axis, that will usually be your time. Okay. So that's rate multiplied by your time. So what happens if we multiply rate by time? So let's take a look at this example, guys. It says here, a snowstorm lasts 24 hours. Okay? The graph below the rate of snowfall as a function of time. So the rate is a direct correlation to our time. So again, our y-axis, in this case, it's a snowfall. It's the rate of inches per hour. I think you guys are very, very much familiar with this. Everybody is familiar with inches on what we get here as here in Chama. So let's say, what happens if we multiply your y, from it's not writing. If we multiply your y, just erase that and go back. So again, guys, what happens if we multiply your y to your x? So what happens if we multiply your y to your x? Why is it not writing? There we go. Guys, any ideas? What will that give us?
You're left with inches.
You're left with inches. Does everybody get that?
Oh,
Guys?
yeah.
So that's y is inches per hour, x is just hours. So we multiply inches per hour to hour, that's just gonna give us a rate, that's just gonna give us in terms of inches. You guys good? Now, going back, so again, this is again very similar to what we've been talking about, but it doesn't give us a steady rate. Okay, notice, okay, it might increase, it might go stagnant, it might increase again, and then it might go stagnant, and then of course over time it doesn't snow forever, that rate may decrease. Now the question is, how would we be able to find, okay, the total snowfall that we have just based on our graph, this whole graph, without looking outside and technically measuring out the total number of inches that we have? Any ideas, guys?
Break it into pieces so you could turn it into like a triangle.
Yeah, very good. So does everybody understood that idea right there? Breaking it down into pieces. That's what Mateo is trying to say. It's breaking it down into pieces.
Yeah.
So like getting an area of a like an odd shape, right?
Yeah. Break it down like at the 4, like from 0.5 to 4, and then
what else?
From 0.5 to 8.
Okay, that's another area.
And then
where else?
You can do 12 to
20,
20, I think.
8 to
And break that into a
12.
triangle.
Can we do this, guys? And then for this one, can we do this?
Oh, okay.
Yeah.
That makes sense?
Yeah.
And then, of course, this one would be another area. Okay, so this will be area number 1. This would be area number 2. We could call this as area number 3. This would just be 4. This would be area number 5. And this would be area number 6. Does everybody so far get the idea?
Yeah.
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 Mm-hmm.
Okay. So we want to figure out what is the total snowfall. Again, guys, length times, let's take a look at this right here. That's
4
so how
times 0.5 times half.
Okay, 4 times 0.5 times half. So let's take a look at area number 1. That will be 0.5, right?
Mm-hmm.
It's a triangle, so that will be base multiplied by height. Oh, wait, let's do, our base would be 4, right? Our height would be how much? What's going to be the length of our height, guys?
0.5.
That's going to be 0.5. And then we'll just move
And then
times 1/2. Very good, because it's the area of a triangle, so that's going to be 1/2 base times height. So you'll have, let me just change this right here. So you will now have 4 times 0.5. That's going to give us 2. Half of 2, that will just give us an answer of, guys, 1. So I'll just place that here. That's going to be 1 inch. Okay. Area 2, on the other hand, that's a rectangle. So that's going to be base or length multiplied by its width. So your length will just then be again 0.5, right?
Mm-hmm.
Your, yes.
Wait, would it be 4?
Yeah, very good. So it's going to be 4. Because from 4 to 8, that's going to be like 4 units, 4 hours. From 4 hours to 8 is going to be 4. So you'll have 0.5 multiplied to 4, guys. What's going to be the product of that?
2.
So that's going to give us 2 inch. And then let's take a look at number 3. It's not writing. Okay, there we go. Let's take a look at our 3. That's going to be, okay, that's 0.5 all the way to 1. So that's going to be 1/2. 1/2. It's not writing again. So that's 1/2.
It's gonna have the same area as 1.
Oh, okay. Our base would be 4. And then our height will be 0.5. Is it the same? Yeah, I think it's just going to be the same. So you'll have 1 inch. Then area number 4, guys. Can you please give me what's the value for our A4?
2.
Oh, it's just going to be 2. So everybody understood where we got the 2?
Yeah.
Okay, so a 0.5 multiplied to 4, that will just give us 2 inch. Let's take a look at area 5. Any ideas of what area 5 is?
Is it 8?
That's gonna be 8. So that's 12 to 20. That's gonna have a base or a length of, what's our length, guys?
8.
8.
Oh, 1?
1. And then our base would just then be 8.
Oh, 8. Okay. I had it.
Okay. Okay, that's okay. So that will have 8 inch. And then for our A6, what will that just give us? That's going to be another 1/2. Our base is from 20 to 24, you'll have 4. Our height is
1.
1. So 4 times 1 is 4. Half of 4 will just be 2. So guys, what's the total snowfall? Let's add them up all together. This is going to be 10, that's 5, and that's a 16. So therefore, our answer for that one will just be 16. Easy?
Yeah.
Let's check. Okay. You guys got that? Or
Yeah.
okay. Okay.
Yeah.
All right. No questions, clarifications. You guys good?
Yeah.
Okay. All right. Let's take a look at this one.
You're gonna have 2 smaller triangles and 1 larger rectangle.
Very good. So can everybody all have it? This is going to be area 1. This will be area 2. And then let's try to have this as area 3. Can everybody agree on that?
Yeah.
Yeah.
Let's try first to read the problem. Okay, it says here it takes 50 minutes for Joe to notice, okay, that his cola bottling machine has sprung a leak. So Joe is able to stop the leak in 10 minutes. Okay, the graph below shows the rate at which cola leaks from the machine as a function of time. So again, it's a function of time with its rate. So according here, how much cola does Joe lose in this bottling disaster? So let's try first to solve area 1. So guys, what do you think is our gonna be? It's gonna be 1/2. What's our base, guys?
50.
That's gonna be 50. Very good.
And then times 2.
And then that's gonna be 50 times 2.
So then
It's 50.
Oh, you guys got it. Very good. Ali,
yeah,
you
got
okay?
it.
All right. Okay, let's take a look at your area 2, guys. What's gonna be your area 2? It's gonna be base. What's gonna be our base? That would still be 50. What's our height?
8,
That's gonna 8. So that will just give us what?
400.
Or 50.
Oh, 450?
Wait.
I thought 400.
No, it's 400.
Yeah, 400.
Danny, you
I
made a
can't do
boo-boo.
basic math, apparently.
Okay, that's okay. That's okay. You made the boo-boo again. Okay, so it's 50 times 8. That's going to be 400. And let's take a look at our area 3. So that's going to be 1/2. Your base is 50 to 60, guys. That's going to give us how many?
10.
10. Your height is? What's going to be your height for this one?
8.
8.
That will still be 8. So 10 times 8, that's 80 divided by 2. That should give us
40.
40. So therefore, you'll have
490.
490 cola
Gallons.
bottles. Is that gallons?
Yeah.
Oh my goodness. That's 490 gallons in after about 1 hour.
Oh my goodness. That
That's
is a bottling disaster.
That is a bottling disaster. So it takes 50 minutes for Joe to notice that his cola bottling machine has sprung a leak. So Joe is able to stop the leak in 10 minutes. So if you notice, this is where Joe was able to stop the leak. Okay, the graph below shows the rate which cola leaks from the machine as a function of time. So therefore, she lost a total of about 490 gallons. Okay. You guys have any questions for this one? I was actually looking for that problem where it takes a little bit more of thinking. Hopefully we could have it on our next problem. Can we guys proceed? Any questions, guys? Clarifications? Okay.
No.
No questions. I hope this is the one. Let's Where's the problem? Okay, I think this would be better. Okay, so it says here, firemen spray water on a house fire. Oh, there's a house fire. Okay. So the spray rate steadily increases until it reaches its maximum capacity. Okay. So the rate is at 24 gallons per minute. So the maximum rate is at 24 gallons per minute. This is our maximum rate. Notice that it does stop off at 24 gallons per minute. Okay. It takes 100 minutes to put out the fire. Okay, and this is how the graph is going to look like based on our problem right there. So how much do the firemen use to put out the fire? So how many areas do you think should we do, guys? Areas. We could do 2. So this would just be area 1. Then this would just then be area 2. Let's take a look at area 1. That would just then be 1/2. Our base is, what's our base, guys?
20.
20. Our height is?
24.
Height 24. Oh, I think this is the area of Wyatt. So Wyatt, what's 1/2 of 20 times 24?
40.
Okay.
Okay, yes?
And then half of that is 240.
Okay.
240.
240.
Sorry, I didn't have a calculator.
240.
That's okay. That's okay. You guys got it? Why we got 240, right?
Yeah.
Half of 20 is 10. 10 times 24 is 240. Let's take a look at our area 2.
1920.
So we got 24. Oh no, our base is, let me just redo that. Our base is 80, right? And then our height is 24. What's our 80 times 24?
1920.
1920. I thought you're talking about a year. That is okay. So guys, 1920 plus 240. What do we have? So how many gallons all in all?
2,160.
160.
Very good. So you got 2,160. Let's check it. So guys, any questions, clarifications? I think this is a lot more easier than Raymond's sum.
Wait, Mr. Moore, will you scroll up so I could like hear of it?
Yeah. If you want to take a photo of it, go ahead.
I want to get the word problem also. But...
Oh, okay. That work now?
Yeah.
Okay. Let me just write down just for you to see 2,160. Any questions, guys? Clarifications? I think this is it. Reina was trying to get in, but for somehow he was gone again. So hopefully she could get back again next time. Any questions, guys? Clarifications? You guys good?
Yeah.
Yeah.
Oh.
Yep.
Okay. So I think this one ends I think we were able to do our objectives, right?
Yes.
Then hopefully by next week, we would then be able to we would then be able to find we will now be able to discuss Raymond's sum. I would highly advise to read on that in advance. I think I was able to already
The assignments are
assign.
Yeah.
And then was that?
Will you unenroll us from the pre-cal?
Yeah. I think I can do that today.
Oh, Mr. Moore, I have a question.
Yes, you have who? Brandy, is that you?
Yeah. So
yes, Brandy.
On like the Google Classroom, how do you take off a class? Because like I'm also on the pre-calculus on the Google Classroom.
Okay, I think I can also take you out, guys, on that part. So I think you guys are gonna be okay. So again, I think the deadline for that assignment is gonna be on the 14th. And hopefully by the 20th, we would then be able to do some integral problems already, like actual integral problems. Hopefully after Raymond's sum.
Oh gosh.
Oh,
no. It's gonna be okay. We're gonna be okay. We're gonna be okay.
Mr. Moore?
Yes.
We only do this until May 7th, right?
I think we can do earlier than that.
May 4th, I believe you sent out.
Yeah, it's gonna be until the 4th of May. That means hopefully by the 4th of May, that's just gonna be ironing things out for your final grades, guys.
Okay.
I understand that you guys were supposed to graduate on the 14th, so it might be a little bit earlier from what I've heard. But up to now, let's just do it all the way to the 4th. And then it might come a little bit earlier. It depends on what what the office is going to inform us. Questions, clarifications, please let me know if you don't see the assignments right away so that we could work it out right away.
Okay.
Okay.
Okay. Okay, guys. Thank you so much. Thank you. Have a nice day and be safe.
Have a good Easter. Happy Easter, everyone.
Happy
It's already
Easter.
gonna be Easter.
Oh yeah, it's already Easter.
Holy.
My.
Virtual Easter egg hunt.
Okay. Yeah, how about we? Yeah, let's look for Easter eggs. Okay, guys. Thank you and bye. By the way, I'll be posting this one on YouTube just in case if you guys need a like something to have a reference on. So this entire classroom will be posted. Okay. See you. Have a
Bye.
great
Bye.
day.
All right,
Bye.
thank you.
Thank you. One session with